Welcome, everyone. Good morning, good afternoon, and good evening. It is a pleasure to have you here today in this webinar. And we're very happy to host more than 30 countries and more than 200 participants here live with us today. I am Dr. Elliot Neto, Ruminant Technical Service Manager for Kemin. And today we're going to be talking about robotic milking, a topic which is bringing a lot of attention in the industry because it involves technology, it involves innovation, and mainly solutions for an industry which is constantly evolving and bringing the best for the producers, the best for the consumers, and the best for our planet. It is a topic that we have a lot of questions, and nothing better to learn from the best. And it's my pleasure to introduce you to Mr. Amir Bloch from Project Bar, which is a consulting group which works globally in the dairy industry, from cold countries like Russia to tropical countries like Vietnam. Mr. Amir Bloch has more than 20 years experience, and he will share with us and answer all your questions about robotic milking, right? And in talking about technology and, very, very relevant topic, we're gonna also address precision nutrition by the robots, right? Which is a topic that Kemin has technologies to support you in this field. So without any further ado, I'll pass the word to Ms. Amir Bloch. The floor is yours, Amir. Thank you very much.
Hello, everyone. Thank you for joining us. First of all, I will share my screen. Thank you for joining us. My name is Amir Bloch. I am VP Nutrition and R&D of Project Bar Group from Israel. Today we are going to speak about robotic milking in your farm. How to succeed. About me, I'm Chief Nutritionist and head of the professional team of Project Bar Group. I have a BSc in Animal Science in the Robert H. Smith Faculty of Agriculture, Food and Environment in Rehovot, Israel. I have MSc in Cows Fertility in the Robert H. Smith Faculty of Agriculture, Food and Environment in Rehovot, Israel. I work as a nutritionist for about 20 years in Israel, and in the last 10 years around the world. I am the main nutrition consultant in one of the largest dairy farms in the world, TH Milk Vietnam. Altogether, 26,000 milk cows, plus 22,000 heifers in Vietnam and Russia as well. About Project Bar. Project Bar Group is a leading project company in the dairy sector that provides management services to the largest dairy farms, feed mills, feed center, both in Israel and worldwide. We have over 30 years of experience, knowledge, and practice, especially in the animal feed sector. We give consulting tailor-made packages to help increasing farmer profit and productivity. Projects vary from feed centers to project management in Israel, Vietnam, Romania, Thailand, Russia, Azerbaijan, Ghana, Rwanda, and more. What are the topics that we will discuss today? History of robots in Israel. Why choosing a robot? Farmers' time saving. Special needed skills. Malfunctions, errors. Cows entries to the robot. Cow characteristics. Buying cost. Maintenance cost. Manpower cost. And my baby, nutrition. And the last topics, maybe the most important from all, tips for success. So my first exposure to the vision of robots was at the 80s of previous century. It was my father, who was a manager of 300 milk cows farm in a kibbutz farm, and he refused to build a new milk parlor. He said, the future is the robots. We are not slaves of the cows. We need the cows to work for us, not us working for the cows. When I look at it 40 years later, my father was partly right and partly not right. He was right because many farms in the world are using robots, but he was not right because not all the farms in the world are using robots. And the reason for that is that the robot system doesn't suit everyone. And second issue is that the management is so important here that you need to manage very well in order to success. Let us begin. The first robot launched in Israel in 1999 in Kibbutz Bet Alpha. And you can see in the picture how they take down and install the robot. And you can see this nice sign of the farm telling the people, hey, we are here, we have robots. Why choosing a robot at all? First of all, no successor to the owner, no daughters and sons to continue, no available workers. Manpower is expensive. Farmer wants more leisure time. Farmer wants better welfare to the cows. Farmer wants to have more milk. Do we really get more milk while using a robot? We will try to answer this. The starting point is very important. Do you move to a robot system from 2 milking sessions per day or from 3 milking sessions per day? If you had 2 milking sessions per day, probably you will get more milk. If you had 3 milk sessions per day, you can get more milk, but you need many entries to the robot. And we will discuss this later on. It's very much management dependent. That means if you work with a very well management, you can get more milk, even with 3 milking, moving from 3 milk sessions per day. Potentially, robotic system should maximize the milking of an individual cow per day. But for producing same milk as milk parlor, you need about 10% more entries than the number of sessions. That means if you add 2 sessions per day, you need more than 2. And if you have 3 sessions per day, you need more than 3. Higher milking frequency will increase milk. When unequal milking intervals will decrease milk. So what happened when we move to robot? The moving to robot system means increasing the frequencies, but making the intervals less equal, because you cannot tell the cow to enter every 8 hours or every 6 hours equally. So who will win here? The frequencies or the interval? So our experience is showing that the frequencies will win. If there will be many entries, we will get more milk. Does the farmer really have more leisure time? So technically I would say yes, he's having more time and more flexible time because no milk sessions. But from the other hand, he must be aware of the robot 24/7. He must take care that there is enough cows entries. He must take care that the concentrate is delivered as planned. He must take care of the malfunctions. Overall, a lot of mental pressure during nights, weekend, vacations is described. It's very much dependent on your character. If you are relaxed and you know that anyway you will get 24 hours alert and you're not afraid to wake up at 1 o'clock at the night and go back to sleep, then it's not a problem. You will not have a mental pressure. But if you're the kind of guy that is getting a lot of pressure because of those alerts, then you will have more pressure. Does the farmer need special skills? Yes, the robot demands higher technical skills comparing to regular milk parlor. But it's not meaning that you need to be a genius. If you have moderate technical skills within time, you will get your experience and know how to deal with many technical issues, many malfunctions. You need to replace pipes and sensors. You need understanding in computers and controller. But this is for sure achievable, and always the young generations, they understand better and better in those things. Malfunctions, errors. Error in the robot would cause a long period of milk reduction. It could take 1 to 3 days to recover from an error. This is why you need efficient and quick technical service. Common errors that we list here after interviewing the many farmers: tiered pipes, tiered liners, broken milking clusters, broken sensors, clogging of the vacuum pump, laser unit problem, feeding unit problem, and problems with the controller board. The numbers of entries per robot. As we speak all the time, one of the most important issues in the robot operation, how to increase number of entries. So the biggest questions of all here, how many cows per robot? Because we need to hold small enough number of cows per robot to allow many entries. But from the other hand, the cost of the unit is expensive. But you cannot win the system if you try to milk 60 or 70 cows per robot unit per day. If you try to do it, you will not have enough entries and you will not have enough milk. And we will discuss the number of cows per robot also later on. Where should the water troughs be? Some farmers in Israel use the practice of restricting water in the yard and giving water only in the yard of the robot in order to force cows to enter. I personally doesn't like this system because it goes against the welfare of the cows. But this is a practice that you should know some people are doing and they have more entries. The composition of the PMR, that means the TMR in the feed bank and concentrate, is very important. From one hand, the PMR should contain lower values, low enough to attract the cow to enter, to search for the concentrate, to complete the feeding values. The concentrate, from the other hand, should be attractive, should be tasty, and should be calling the cow, come and eat me. And we will discuss this later. Should we push the cows to enter? The answer is completely no. The robot system is built that you don't push the cows. You let the cow decide when to enter. If you try to push and rush them, you will not end up in more entries. Cow characteristics. Do we need different characteristics of the cow while operating a robot? Yes. Some cows could not be milked due to the shape of udder. All the laser and identifying units are improved all the time by the companies of the robots, but still they have some hard time to connect when the shape of udder is not convenient, big or a large distance between the teeth. Also, some cows will always refuse to enter. They will be afraid. So you need to consider that some cows that you really like will need to leave the herd. Should we keep a small milk parlor for such an issues? Big udders, mastitis, treatment, cows afraid to enter. So probably the answer is no. It's convenience. This way you can, if you keep a milk parlor, of course you could keep more cows or make treatment. But from the other hand, it's very costly. You need to pay more for milk parlor, more for maintenance, and it goes against your leisure time strategy. So my personal answer is not. I would not recommend such a step. Buying cost. It would be around, for one unit, 170,000 US dollar, about 150,000 euro, including the concrete and the structure. And I understand that it could vary between the countries. And this is what we face in Israel. Maintenance costs. We divide the cost for the retainer that you pay monthly for the technical support and for the cost of particles. So the service would be around 9,500 US dollar per one robot unit per year. Plus particles, 1,500 US dollar per one robot unit per year. Altogether, 11,000 USD per one robot unit per year, which is much, much, much higher than what you spend for a regular milk parlor, maybe 6 or 7 folds higher. From the other hand, do we really save manpower? The answer is yes, around about 11,000 US dollar per one robot unit per year. This 11,000 covers the 11,000 of maintenance that we spend. So actually the saving is, or you can say that what you spend on the maintenance is saved by the saving of manpower. But we need, even though we save manpower, we need to remember it's not a send and forget. We still need to handle the alerts. We still need to run the routine of the farm, excluding the milking. Moving the robot doesn't mean that now I do less management or that I can afford less or less quality management. I still need very high management, maybe even better. Overall, the labor saved is half a worker price per robot unit. We got to the nutrition, my baby. We will speak about feed bank PMR formulation, concentrate formulation, how much concentrate per cow, solids in milk, feed efficiency, cost comparing to regular TMR system. Let us begin. Diet in the feed bank. How do we formulate? So the practice that we use in Israel, and it is not gold standard practice, but this is what we do in Israel and many times successfully. First of all, we are formulating a well-balanced diet. Second, we extract the concentrate from the diet. The remaining, after extraction of the concentrate, is a TMR, containing lower energy and protein and higher forage. How do we formulate the concentrate? So as we said, we extract it from the total balanced ration. What characteristics should it have? It must be tasty to attract cow to enter and eat. It needs to be pelleted in order to flow in the pipes, and those pellets should be strong. How should we make strong pellets? We should include high degradable starch inside. That means a certain amount of wheat or barley grains. But remember, too much wheat and barley will cause us acidosis. Then we need to find the certain amount that will of wheat and barley that will give us strong pellet, but still will not cause us acidosis. And the rest will be corn grain and some meals. What about the buffers? So it's not recommended to include the buffers in the concentrate because not always it is tasty, and we want the cows to eat very well. Vitamins, I would say that it may be better practice to include the vitamin in the concentrate, because in the robot you could control the intake, and this way there is no waste of vitamins to a cow that eating PMR and eating vitamins, and sometimes the cow are eating too much, more to cover the production, and then it's a waste of money and vitamins. Special additives, such as bypass amino acid and chromium and organic minerals and yeast and more, where should we include them? PMR or concentrate? So let's speak about this. Trials with self-timer feeders revealed very big differences in dry matter intake between cows having the same milk production and days in milk. Two cows could produce 50 liters per day, but one cow could eat 25 kg dry matter, and her friend could eat for the same meal 30 kg dry matter. So many groups in the world now are working to find a way to find those cows who are eating high amount of dry matter intake. Because if we know that some cows are not efficient, maybe it will change our way of culling cows. And I know it's cruel for the cow. The cow is not for to be blamed if she eats too much. But this is how it works. Because some cows could eat a lot, it is more logical to feed special additives such as bypass amino acids, choline, chromium, organic minerals, yeast, and more in the robot, where we could control the intake. There is also a chance that missing essential amino acids and other essential nutrients will attract cows to enter the robot. We could discuss this issue, how to attract cows to enter the robot, in the discussion section. How much concentrate per cow? Some farmers in Israel, they use the practice of giving just a regular TMR in the feed bank and attracting the cows to enter the robot with only 0.5 kilogram concentrate per day. This practice sometimes works, but sometimes there are not enough entering per cow because the TMR is high quality and the cow actually gets enough from the TMR. So sometimes it works and sometimes not. And our recommendation is to follow the manufacturer recommendations to give 3 to 8 kilograms, depends on the production of the cows and days in milk. And if you follow this, usually you get more entrances and higher milk. How many silos of concentrate per robot? The robots are designed that in a way that you could connect 1, 2, 3, sometimes 4 silos. In Israel, we connect only 1, but I think it would be better to connect 2 or 3, because this way you maximize the value of the feeding and the cost of the feeding all along lactation. And you could save money if you give for low yielding cows lower value and lower price concentrate. Solids in milk. Usually there is less milk fat. It is hard to balance the total diet and avoid acidosis because every bite in a regular parlor, every bite of the TMR, the cows are eating equally, homogenic. But in the robot, sometimes she's eating concentrate and sometimes PMR, not in the same time. And when they made a survey in 2 herds that moved, A and B, that moved from a milk parlor to a robot system. So if we speaking fat percentages terms, one reduced from 413 to 396 and the other one from 396 to 382. Optional solutions are there. In Project Bar, we developed ways how to overcome the solid issues, but there is a cost and sometimes high cost to it, but we could discuss some optional solutions, how to keep high fat in the robots later on in the discussion section. Feed efficiency. With the robot, it's harder to calculate because you need to gather both PMR intake and the concentrate intake. But I think it's very important and not so, and it's achievable. And I think like we have in a regular Excel sheet or some sheet that we calculate every day, how much dry matter to produce the liter, or how many liters are produced for 1 kg of feed. So I think it's also worth, and we recommend it, it's also worth to calculate daily how much they eat. You could know from the computer of the robot how much concentrate was eaten, and you know PMR, how much was eaten, and you could have your feed efficiency figure, because you could lose your trousers if you don't check how much they eat, and sometimes you pay too much on eating, and it's much harder to balance the nutrition when you have concentrate from one side and PMR from one side. You want to make sure the cows are not eating too much. What is the cost of feeding comparing to a regular TMR system. So our surveys revealed it will be more expensive, 6 to 8%, to feed in a robot system. One of the reasons for that is the cost of concentrate. You need to pallet, while in TMR you give it mash, and you need to include expensive grains inside and expensive meals in order to attract the cows. And you pay extra cost for the feed meals. So we in Project Bar are aware of this, and we are trying to find cheap solutions for a good concentrate in the robots that will not cause acidosis and will be cheaper. For example, to dry brewery grains that are considered very tasty, or to dry citrus pulps that also considered very tasty, both will not cause you acidosis. We got to the last section, tips for success. We gathered many points that could help you to succeed with the robot. Probably there are more, and people from around the world using robots would give you more tips, but we gathered a lot of them to help you understand the issue. First of all, do not interfere the hierarchy of the herd. Let the cow decide when to enter. If you try to push them, it will go against you. This is how the robot works. You do not need to interfere. Make all robots available for all cows. That means at least you hold for 80 or 90 cows 2 robots, because if some error occurs, you need the cows to go to the other robot, and they need to know and be used to the other robot. It will help a lot, and you will not have this 1 to 3 days of reduction in milk when you have an error. Hold maximum 40 to 45 cows per robot. Depends on the yields, but don't be tempted, as I said before, to save money and to hold 60 or 70 cows per robot, because this way you will lose. We know it's costly to install the robot, but it's more costly not to have your milk. Leave 10% free time for the robot for maintenance, weak cows, and more. That means the times that the robot could be empty. Let the young heifers suck from the mothers until weaning. This is not a must recommendation, but we visited a very nice farm. And the idea in this farm is to let the offsprings to suck from the mothers twice a day. This way, the first lactation cows are not anxious about their offspring, and they enter much more willingly to the robot. Instead of 2 weeks getting used to enter the robot, sometimes it's less than a week, just because we took some of the stress out of the mothers. Use the robot manufacturer recommendations for amount of concentrate. Those companies, they have a lot of experience about the robot, and we should listen to them. You can change a little bit, right or left, but overall, if you keep their procedures, you will get more entrances and more milk. Don't push cows into the robot. Only after 12 hours, check why the cow is not entering. Close to dry off. Do not force to enter. It's a very good way to dry the cow gently and naturally, and you don't need to get hysterical if the cow is entering only once a day, because now the cow is not having so much milk and needs to be dried. Keep available and quick service near to you. Keep spare parts at the farm. And if we get to the point that you can fix more than 80% of your errors in the robot, then it is success. Then most of the time you could continue milk your cows without any harm. Keep the cow genetics aimed to other shape to reduce the number of cows that could not be milked. Very important point, the weighing of concentrate in the robot is weight to volume system. It is needed to be calibrated once in a while. Not always the pelleting in the feed mills is homogeneous, and the weight to volume is not always the same, even with the same composition of concentrate. So you need to calibrate it in order to be sure that the cows are getting the right amount of concentrate. How to cool the cows? So cooling by high pressure system or at feed bank, but never interfere the cows by taking to a cooling yard, because this could mess up a lot with your entering and with the hierarchy of the cows. And last tip, maybe the most important, patient, patient, patient. You need to learn how to flow with the robot, not to try to teach the robot how to flow with you. Questions will be answered in the discussion section that will come directly after I finish now. The discussion section will be handled by Dr. Elliot Neto, our friend from Kemin. So thank you very much for joining us and listening. I was Amir Bloch from Project Bar. My contacts are listed here, and you are more than welcome to be in touch and to ask any question that you like. Thank you very much again.
Thank you very much, Amir. And I'm sure all the participants have learned a lot of good information. As this is a very burning topic, and I think now is going to be very productive as well. We have a lot of questions coming from the participants. But before we go to our discussion, I have some polls to share with the participants. So Amir, if you could please unshare your screen. Perfect. So I'm just putting the poll here. Can you see the questions? If anyone can give me feedback. So we have 2 questions here for the public. Just please answer that to us so we can read the results for you. And this will be also good, interesting information. So the first question is, how do you classify yourself in terms of the robot utilization? Are you currently you have currently a robot in your farm, or you're considering one soon in the next 5 years, or you don't consider one robot for now? And number two, in terms of robot milking, how do you see the best opportunity? You can save labor and free up time. And the other options are there are opportunities to feed additives via the pellets. And the number three, improve animal welfare and milk yield per cow per day. So I'm sharing the poll here. We have
Elliot, we are sharing already. Yeah.
you're sharing? All good?
Yep, all good.
Okay. The poll just popped. Perfect. So let's while we wait for the answers, let's start with the first question for you, Amir. Just to kind of break the ice here, and I'll play a little bit about the devil's advocate, right? You said your dad used to tell you that robots would be present at this day in the industry, right?
Yes.
And you said that he was right and wrong at the same time, because yes, some producers have robots, but others don't. I would argue that probably in 20 years' time, all the farms will have robots, all the dairy farms. What do you think, Amir? Do you disagree or you agree with me?
Disagree,
Okay, and why is that?
because I think it doesn't suit everyone. And I think maybe for a very large operations, it would be hard. Very large operation, maybe you need to divide. Like maybe it's a big operation, I don't know, 10,000 cows, but it should be divided to 200, 200, 200 sections with, I don't know, 5 robots in each section and with the managers to every part. But it doesn't suit everyone, and it's also a matter of the cost of the labor. In some places was still the labor. In some places where the labor is still very cheap, probably, or cheap, or maybe they want to give organizations, they want to give work to the people, maybe for them will be better to keep a milk parlor system. But I think more farms will get robots, especially the ones with the expensive labor and with no ancestor to the owner of the farm, or maybe very hard to get workers, so they will do it. And from time to time, the companies of the robots, they make a better machine. So I think it will come. Also, maybe the price would be cheaper. You know, maybe 40 years ago or 50 years ago, you remember the videos. So to buy a video, you needed a mortgage. It was so expensive. But afterwards, the video was very cheap. So the same could be with the robot. Yeah, probably they will find an advanced way how to produce it. And or maybe they will produce it in a certain countries where it would be much cheaper to produce. And then it will be much more affordable for the farmers, and they will do it. And also they all the time makes it better, that identifies the cow and less problems, less errors. So it will work better. I think more farms will have the robots, but not all of them.
Yeah, thank you very much, Amir. So we have some questions here. I start with one question from the participants here. Do you have experience or what do you think about robots for other breeds other than Holstein cows? Have you seen that? What do you think? Are they possible?
You mean for sheep and goat, for example?
No, other breeds like jerseys.
Breeds
Yeah,
like Jersey or
Jersey or
yeah,
different types of zebu.
Simmental, Jersey. I don't know.
Yeah.
I think why not? If I see, I never met such a place, but for sure, Jersey, who is giving less milk per day, so the cow will not stay in the robot for so much. So maybe in Jersey you could hold more cows per unit, and maybe it would work. I don't see why not. But you need, of course, you need to design the robot for the size of the breed.
That's right.
But I don't have experience. Probably the companies have some experience with this. Maybe
Okay.
some people from US here that having a lot of jerseys, for example.
Yeah. Thank you. Let's move for the second question here, Amir. If we have only one section for all lactating cows, how is better to manage with essential vitamins and microelements? The fresh cows need more of them, but the intake of concentrate is lower than for the high cows. In this case, would it be better to put them in TMR or not in the concentrate?
In in Israel, for example, we don't have fresh groups. We don't use the practice of fresh groups. It's one TMR for all cows because not enough cows in the fresh groups all the time. I think after calving cow will eat enough concentrate. I don't think there will be a problem because they like to eat the concentrate. So if they eat 3, 4, 5 kilograms, they will get enough like amino acids. Also, after calving, the dry matter intake of the TMR is not high. It takes time until they go up. So I think still it could be amino acids in the concentrate, and it could work well. Also, we could half it, like put some in the concentrate and some in the PMR. It's also a solution that if a cow could consume a lot of concentrate after calving, she will have enough. And if no, she also have the PMR as a backup. There is no, I think there is no one answer to this. But I never heard also about university trial testing those approaches.
Yeah.
Still, I think not enough robots in the market to push universities to make those trials. But I think when more and more farms will use robots, and the universities will have more budgets to test those issues.
Yep. Thank you. We have lots of questions coming here, Amir, and I'll pass for the next one. With a system where cows are RFID tagged, is there work being done now in getting the robots to learn the cow's milking tendencies and alter its tendencies by cow? Do you know any kind of work that is like, I'm not sure if I get the question, if the robots.
Could you repeat the question, please?
Yes, of course. With a system where the cows are tagged with an RFID tag, is there any work being done in getting the robots to learn the cow's milk tendencies? Yes, I think the robots, they know, right? Or, I mean.
Yeah, of course. Yeah, the robot, I did not hear about a walk that was
Yeah, I think
measuring it, but
I think the question about the milk tendencies will be if the cow is milked 3, 4, 5 times a day, and what of the times the cows are milked, and if there is those tendencies or there is the gap between milkings are not
I
symmetrical.
don't. I did not read the work about it, but interviewing the farmers, they said not always it's the same trend for the same cow. Sometimes the cow will enter every 4 hours, sometimes suddenly 8 hours, and then again 3 hours. But this is only like rumor from the farmers, not a trial that I read about.
Yeah, I mean, and I think it's like let's say the necessity of the cow for being milked, right, will change depending on the day on her. Like if one day it's hotter and the cow is drinking more water, or so different changes in the environment. That's why the cow will be milked, from 3 hours or sometimes every 5 hours. There is some changes, as you said, right? And the question here is, can the robot fix that and let's say open the gate only every 4 hours? Do you think that would be good for the cow, Amir, if the robots just try to make also the cow another robot?
I think it's not. It would not be a good practice to try to put the cow into milk sessions again. You need to let the cow be milked in its time. Of course, if the cow is entering only to eat, after half an hour, it will not give the cow to enter, because she's not coming for the milk, she's coming for the concentrate. But if enough hours pass, and I don't think you should say, okay, 3 hours, no, 3 and 15, yes, or try to make the cow used to enter every 4 hours. But for sure, I think I need to read more and more about if any trials were done, and I think the industry should push more and more trials for learning those habits and how to get the best out of your robot.
Yeah, that's correct. I agree. I think it's also the science of animal behavior, right? It's and ethology, it's growing pretty fast. So that goes hand in hand with the more utilization of robots and the better understanding of what happens inside of the brain of the cow. I think that will create, new techniques and new management strategies.
Yeah, because the cow could not speak yet, maybe yet. So we don't know. Like, for example, you try to screen, the habit of gathering in the yard. Gathering is the yard that the cows are standing in a certain spot in the yard. All the cows together in the heat, very hot temperature, and instead of spreading nicely around the yard, they all the times gather in one spot.
Yeah.
And we break our heads many times. Why? Why they go there? Maybe more air flowing, maybe we don't know exactly. Yesterday, I visited such a farm that all the cows were standing in one point, and not always we know. So of course, we need to learn all the time about what is going on in the mind of the cows, and this way we will understand more and get more.
Very good, very good. We have a question now, Amir, about number of cows per robot. Okay. You recommended in your presentation no more than 40 to 45 cows per robot. But if the average of the yield per cow per day is about 30 liters, could we put more cows per robot?
The question is, what is the reason for your cows having 30 liters? Um,
No, no,
is
Amir.
is it a genetic issue or fertility issue? Maybe the highest days in milk. For the robot working well, you need excellent fertility. Excellent fertility because you want to, all the cows have high milk, and you don't want many cows enter the robot with I don't know 15 liters, because also this takes a time for the cow to enter, to identify. Robot decides if to refuse or not. Also, this is a waste of time. So it's better to have good fertility, high yielding cows. So I am not sure if you have 30 liters, yes, maybe you could hold 50. But what would happen afterwards when you improve your management? And now cows, they want to make 40. And then there will not be enough. There will be too many cows per the robot. So you need to be aware of that. I think if you have a 50 cows herds, then maybe you buy one robot and start to learn it. And then if you see that your cow could achieve more, maybe sometime you need to enlarge your herd a little bit and then to have more robots. But the 40 and 45 is not a gold standard, but the meaning is to tell you that be aware of that, because the number of cows is one of the most important. If you try to milk many cows, too many cows in your robot, you start to lose. The cows will not give enough milk, and then you will not know what to do. So this is my recommendation. 30 liters, probably, maybe you could fit 50, but you need to watch. You need to watch, okay, 50 cows, one robot, 30 liters. You need to watch how much free time the robot has. If you see only 1% free time or no free time, that meaning it's too dense. You need to reduce the number of cows per the robot.
Okay. So I think, Fran, you can share with us the results of our poll so I can read to them the results. Yes, thank you very much. And in the meantime, while I discuss here the poll questions, please keep sending your questions, please. So from our polls, the first question was, how do you see yourself in terms of robot utilization? How do you classify yourself? So the majority, 42% from this webinar said don't consider one for now. 37% said I consider one robot in the next 5 years. And 21% said I currently have a robot in my farm. So it's a pretty even distribution, I would say. If you put the group of having a robot in 5 years plus those who don't have a robot or have a robot right now, we're talking about maybe 60% of the people versus 40 that don't consider. And the second question, in terms of robot milking, how do you see the best opportunity? So almost 50%, 47%, I can save labor and free up my time. So that's spot on, Amir, just as you addressed in your presentation. Labor is the main issue or the main benefit of having the robot. 32% improve animal welfare and milk production. So we can discuss that a little bit more, Amir. And 21% opportunity to feed additives via the pellets and vitamins in the robot. So thanks everyone who have answered our poll here. That's give us an idea about the industry tendencies and what people are kind of planning for the future of their operations. So to link to this discussion here, Amir, what is your expectation, or what is the physiology behind feeding rumen protected amino acids via the pellets? Do you think it will help to bring the cows to the robots, and why is that?
So what is standing behind it? So one point is that we could control the dry matter intake in the robot, where in the PMR we could not control. And that means some cows will just eat too much amino acids and when they don't need. It's not a harm, it's harm to our pocket. So we could save money if we feed them in the robot. The other issue is to attract the cows. So trials should be done about this to see what is the cow searching for in the concentrated. Is she searching for the taste, or is she searching for the missing nutrition materials? So, okay, we give less crude protein in the feed bank. Okay, what is missing to the cow? Is the cow speaking to herself, saying, "Oh, I don't have enough methionine and lysine. I would run quickly to the robot," or what is going on? So I think intuitionally, the animal feels somehow that there's missing lysine or methionine. And of course, she's not speaking to herself, but she will look for it. So I think it could theoretically be a good practice, but it needs to be supported by good trials.
Good. Thank you. Let's go for the next question here, as we still have a lot of them to address. This one is already being addressed here. Let's go for the question about there is a question here. Would the robot milking system produce more data for the dairy farmer? And would that data help in the decision making about the nutrition processes?
So the answer to this, there is a lot of data achievable also from the regular milk per law. But in the robots, the high yielding cows, they enter more times, not only 3 or 2. So you get more times that the cows is visiting, identified, and you could learn about the flow of milk and the conductivity and other things. If you could take better decisions, it's a question. It's a question if you could take better decisions while working with robot, yes or no. I think if we analyze well the entrances of the cows and how much milk per milking, then maybe we get a little bit more information of the high yielding cows from the robot. You know, once in Israel, many years ago, they said we want more milk, so they did not move to robots. They tried to milk the fresh cows until peak 4 times per day. They thought it will give benefit, but it was not a great success. I think the cows lost too much body condition, and it was not, it was stopped in a while. But I think there is need to learn. There's a very big data in the robot. So if it will be analyzed statistically, how many entrances per cow, and what is the interval, and what's the frequency, and how fast the milk flows, I think we could learn a lot about this, about the habit of the cows. And maybe it will also allow us to decide about some cows, if are efficient or no. So I think a little bit more data you could get from the robot, but of course, the problem is always you have thousands of data, okay, kept in your computer. What do you do with it? So I think we companies, consultants should help the farmer to simplify this thing, to take all those data and makes them for an action item. Okay, I have so million of data, now action item for decision. I think it will be a good task for the big consulting companies to make action items out of it, which cow to sell or how to treat differently, or maybe it will give you alerts about the nutrition. But many trials should be done about this to help us.
Yeah, no, I completely agree, Amir. I think it's yeah, it's gonna be as you mentioned, the task for the consulting groups to take, let's say, 1,000 pages of data and numbers and produce 2 bullet points. Here you change and here you change, right?
Yeah, what to do? Yeah, what to do?
Yeah, yeah, and what to do, that how you're gonna maximize the production of your cows, or how you're gonna change the diet so that you can cover some deficiencies and things like this. Before we move for the next question, I have a reminder for everyone. In a week time, on Thursday, the 24th of February, exactly the same time, we're gonna have our second webinar with Amir Bloch about heat stress management of dairy cows. So I'll be hosting that as well, and you're more than welcome to attend us again. And please invite your colleagues that might benefit from this information. Again, Project Bar has global expertise in terms of management of heat stress in dairy cows, and that is a subject, or there is an issue which is probably eating a lot of your profit in your operation. So understanding how to manage, which are the new technologies, that will be very useful information for you. Okay, so just a reminder for next week. And for the next question that we have here for the robot, what was the highest milk production you have seen from a robot farmer? I have seen 2,800 kilos per robot. What is the highest milk production you have seen in a robot per cow per lactation? I'm assuming.
Only I did not hear how much he faced. It was how much?
Okay, so it says here, I have seen 2,800 kilos per robot. So
it means per day?
no, that's probably per lactation. If you ask that question, can you please clarify?
Clarify what it means. How much milk per what? Per cow, per robot unit?
Yeah, yeah, it says.
I could say what we see. We could see, I don't know, robotic farms that milk 40 cows every day with 40 liters. So if 40 on 40 cows on 40 liters, it's 1,600 kg milk per day.
Yeah, so this is, I think that's the question then. You said it's 1,600, right, kilos per day, and
Yeah, 1,600 if it's a 40 on 40 cows, yes.
yeah, he's mentioning here he saw 2,800 kilos per robot. So
Yeah, this is enormous. For how many cows? Could you ask him? The
yeah,
228.
so please, can you also give us more detail about your question if you are here with us?
For how many cows? It's really huge.
Yeah, I agree with you. That's
I saw maybe 1,600, maybe, yes.
yeah. Another question for you here, Amir, and I just another reminder here, we are finishing in 9 minutes, so there will be 9 minutes sharp, which it will be 3:30 p.m. Singapore time. The questions which are not being answered, we're gonna reach out to you with the answers later, okay? So bear with us here. Another question, Amir, how long does it take to train the new cows that are going to the robots?
So the description from the farmers is the first lactation cows, sometimes it could take 2 weeks. But the adult cows, maybe 1 day, 2 days, no problem. But your biggest challenge is the first lactation. And then I described this farmer who is letting the offspring suckle from the mother, and that makes it shorter. But you need patience. In the end, all the descriptions are saying that in the end, the cows will enter. But you need patience to slowly teach them how to enter. But sometimes it could take 2 weeks per a cow.
Yeah, as just as you mentioned in your last slide of the presentation, patient.
Yes, yes.
So our participant here answered your question, Amir. It's 64 cows per robot.
So
And
it's to 2,800,
2,800,
right?
yeah.
64.
Correct.
It's like 43, 64 cows. This sounds enormous. If we could do it, we were millionaires, but maybe yes, to 64. 44 liters, 44 liters for a kilogram for 34 cows. So yes. So I did not, I haven't met such. It's enormous, but maybe it could share with the farm, with the place, with the kind of robot management. We would be happy to learn from this.
Yeah. Another question here, Amir, and I think that question involves a little bit of the economics, and I think your experience will be very important. What is the minimum number of cows that you need to have to use a robot? And I can start answering this a little bit because I had a conversation with a nutritionist from Spain, and he was telling me that the Spanish government is paying for 50% of the robots. It doesn't matter the size of the farm. And that was because of succession problems. So the country needs to keep its supply of milk, but there is a lot of farmers that want to retire, but they don't have the next generation or the son or the daughter that they don't want to work on the farm. So the government pays for 50% of the robot so that the farmer can still become older and still operate and produce milk for that country, right? So again, subsidy is an important consideration about the robots, so it will allow a small farmer to have one. But Amir, what is your experience without subsidy? What's the minimum amount that of cows to have a robot?
Minimum, I don't think for 20 cows it's to pay 150, I don't know, thousand euro per 20 cows will return your money. So I think the minimum is to fill one robot, like 40 cars, or this is what I think, but our experience had never been less because the herds are not so small. In Israel, there is a quota, and people, they have much more than 400,000 quota liters per year. So anyway, they have more than 40 cows. Sometimes you could buy cheap units, then people, I met farms that holding 35 and 35. But this is because they bought the second unit cheaply. But if you have to pay the full price for the robot, so I think you need to fill it. Because you pay for maintenance and for the cost of the robot the same. Doesn't matter if 20 cows or 40 cows, so it's better to fill it.
Yeah. Yeah, I have a lot of people, a lot of participants here, Amir, saying thank you, very interesting. I'm not gonna be reading any specific names here, but looks like a lot of people from there's people from Africa here, from Asia, from Israel, everyone saying thank you very much for the information. And one comment from one participant here, there is a great collaboration opportunity for dairy robot manufacturers and companies that produce ingredients for feeding to investigate and understand the nutritional needs of dairy cows as the lactation cycle progress. So I agree with that. We need to better understand how the robot is changing the physiology of the cows and how we can utilize nutritional technologies to feed in the pellets and also maximize the production of the cows. That's a good comment. You want to add anything, Amir?
Yes, I totally agree. I think we need to study more, like we do with the regular farms. We all the time try to find solutions, cheaper solutions for the farmers, because the costs are always high, always increasing, and they need to keep the same production with the cheaper nutrition. So the same acts for the robots. We need to find ways how to make it cheaper and better, not more. Usually our approach in Project Bar is cheaper and better, and not more expensive and better. So the same with studying the nutrition of the robot could give much money to the farmer if we study it well, if we spend time on it.
Yeah. So I think we are in the last minute for the presentation. On behalf of Kemen and Project Bar, I would like to thank everyone again for the great questions, the great opportunity we had. Amir, it's been a pleasure to have this collaboration with Project Bar. Just a few names here. I said I wouldn't read names, but there is a lot of people. There's Andrea Murphy from New Zealand. Thank you. Alexander, thank you very much for saying good things for his. Harel Levit from Israel saying thank you. Guy Goren, also from Israel, thank you very much. Shiamal Das, thank you. Surio Firmanto. So all of great people. Amir, your final words, please, before we go.
Yes, thank you very much for joining us. It's always a pleasure to meet with the farmers. Actually, we work for you. You are the one who give work for us, and we thank you very much for this, and we never forget it. That we work for you. You don't work for us. We work for you, and we never forget it. And always I learn new things when I visit the farms. I always learn new things because you have the experience. You touch the cows every day. You touch the robot every day. So thank you, and thank Kemin. Thank you, Kemin, for joining us in this program.
So with this great comment from Amir, see you everyone again in 1 week time with the topic heat stress management in dairy cows. Thank you, everyone. Until next week. Thanks. Bye-bye.
Bye-bye. Thank you.